We'll dive in here. It's an essential component, ventilation, commissioning, and duct leakage. As a result of that, we all are very used to focusing on the enclosure um, and the leakage, the airtightness of the building enclosure, not so much on the ventilation duct work. And so we want to raise that awareness and dive into the details. There are credits available both from the AIA and PHI. You can email training@passivehousenetwork.org to receive certificates, and we'll follow up on that as well. Now, before I introduce our speakers, I do want to just mention we have, if you can see this, a hard copy of the Passive House Awards book, the 3rd edition. Beautiful book, projects all over the world. We're going to take everybody who's joined us today on Valentine's Day, attending this session, put your names into a hat, and the lucky winner will get in touch with you, we'll follow up and mail you the book. It's a great resource to have. So with that, without further ado, I'm glad to introduce Kelly Fisher and Michael Schmidt. Kelly Fisher is a senior passive house consultant at Peel Passive House Consulting and is a passive house building certifier with 7 years experience in the passive house industry. She has 15 years of experience in the construction industry in various roles, and her interest in passive house really sparked the shift to address, how we're going to build better buildings, operate better buildings, and have them be contributing to a better world for future generations. At Peel Passive House, Kelly manages certification consultancy on projects of all sizes and types. Good to have you with us, Kelly. And Michael Schmidt, senior building systems consultant at Stephen Winter Associates, focusing on performance testing, field inspections, and verification of energy efficiency measures on projects pursuing passive house certification. Michael's a certified passive house tradesperson and certified verifier. He's worked as the primary field inspector on numerous passive house certified projects of various sizes across the New York City tri-state area. Welcome, Michael. It's great to have you both here. I will stop sharing, and to just know that Peel Passive House and Stephen Winter Associates are really two of the leading firms in our growing bigger buildings, more complicated projects. Thank you, Kelly. Go for it.
Thanks, Ken, for the lovely introduction there. I'll just say it again. Hi, everyone. I'm Kelly Fisher. I'm an accredited passive house certifier, trainer, and certified passive house consultant. Today, Michael and I are going to share some of our experiences on multifamily buildings with respect to duct leakage, and offer some solutions and maybe some things you can carry in design to kind of help alleviate struggles that we often face. So I'm going to be kind of talking about things more as from a certifier perspective, just because we get a lot of submissions that end up taking a lot of time and delaying projects and that sort of thing. And I think Michael will come at it more from his site perspective and the consulting role as well. So we'll have a wide kind of array of interesting stories that have happened and some solutions that maybe you can employ for your own projects. So a bit of an agenda today for my part of it. I'm going to kind of get into some of our struggles on past projects with balancing deficiencies in documentation. And then Michael, I'll transition over to Michael. He'll explain kind of the same things, maybe some different aspects of process that he's run into. And then we'll both share our solutions for success and kind of how we've kind of figured out how to make this work a little bit easier for ourselves. So for multifamily ventilation, these systems are quite large. So I have a couple of schematics here that I wanted to kind of show you just because they're a lot bigger than a single family home. You get into these really large duct networks, really large kind of ERV and ventilation units. And, there's a lot of little bits and pieces that get in the way of balancing these and creating pressure loss and creating issues if it's not documented properly or built up nicely. So kind of some examples of some larger units that we've got on some of our projects. So we've got this week on rooftop units and then some really large kind of gold 50 RX units. So really, really large ventilation units that go quite high on the realm of what they can offer for ventilation. So a lot larger than what you would run into for single family homes or even some of the smaller multifamily projects. And with these larger units, we end up with a lot more kind of built-in components, a lot of ductwork that's required to accurately distribute or adequately distribute the air throughout the building. So on the left here, this is a cooling coil that's integrated into a venticity unit. We've got a really, really big indoor Suigon 50. As you can see, it's really, really tight ceiling and the clearances in this particular project. And then here's an example of a duct shaft that we're looking at, where there's a multitude of different ducts that are running in these shafts that can create hurdles when we're looking at balancing and trying to find leakage and that sort of thing as we go through. So a bit of the lingo. I find that there might be some differences between how Michael explains things and how I explain things. So I try to use the PHI abbreviations for things in my slides. So I just wanted to kind of put this in here as a reference point for anybody who might kind of get mixed up with some of the abbreviations that I'm using. But with multifamily ventilation, we end up with a lot of really long ductwork. Here's an example of I believe this was a 10-story project. And there was roof-mounted ERVs that go down distribution vertically into all the suites. So it goes from the roof of a 10-floor building to the ceiling of the second floor. This particular project got AeroSeal on the ductwork. So it made it really easy to understand if there was going to be any leakage, but we still needed to be mindful of proper design and testing those pressure losses with the mechanical engineer through design to make sure that while we are designing a system that is going to be tight and mitigate that leakage, we still need to make sure that it can perform properly. So making sure that you're doing the calculations and fully assessing all of the little components that run in your ducts. And I've got some examples of what those look like here. So when we have these large systems, we end up with, well, in Canada anyway, especially Ontario, where a lot of our projects are located, we end up with fire and smoke dampers through every fire separation. And when you're looking at how this impacts your design, if you have 16 suites that are being serviced by an ERV, every time it goes into a suite wall through a duct shaft, you have to have a fire smoke damper. Anytime it comes through a floor, depending on where it's located, you also have to have one of these dampers. If you're ducting directly into fan coil boxes or through a VAV, for example, to help regulate airflow, you're going to end up with leakage along the way and pressure loss, because each one of those devices or duct accessories will incur more loss. It'll interrupt the airflow from the ERV. And if you're not looking at appropriately sealing those or having an understanding of how to include those in your calculations, you will likely end up with issues by the time you get through to commissioning and measuring your flow rates to see, okay, yeah, we totally missed 16 dampers and our calculations and design didn't work, which does happen from time to time. Can you believe it? So being mindful of your duct accessories, their tested leakage, and how to incorporate that and understand that in design is really important. Not realize this one had animation, so we just get everything up here. So the pressure losses when we're talking with these for multifamily buildings is something that we have to consider that we don't necessarily have to do for single family homes for passive host certification. But every component along the way, whether it's an elbow or a silencer or a cooling coil or filters, all of these incur different losses through the duct network system. And making sure that we account for those on the longest duct run in the building and weighting that against what our machines can provide is very important in design. And then following through with making sure that all those components exist and are kind of included in your project as specified is very important as well, so that you don't incur additional losses. So when we're looking at pressure loss calculations, these are required for non-residential and residential buildings when you get into that larger than 600 meters cube per hour. So I've got some links up here. I think Ken's going to share some of the presentations after, perhaps, maybe. But these links here are really helpful when they come from Passipedia, which is the place where we go and we find information as passive house designers that comes from the Passive House Institute. And there is some information on how to do these calculations. There's no restriction on the tool or the software that you use. PHI does have a tool that's available that you can download from Passipedia. We found when we were reviewing it, it's really great for like smaller projects, but when you get into larger projects, you just take the same Russian, develop the spreadsheet a bit differently to make it. So when we're talking about pressure losses in general, we find that a lot of our losses come from dampers, fittings, and filters. So being mindful of making sure that those are included in design, those are properly sealed so that, adjacent ductwork is really, really important, so that you don't exceed what your machine can provide to you. So in addition to issues that come from like leakages or different filters and components and accessories, we also have a lot of other kind of deficiencies that come up when we're looking at, if you're measuring your airflow through your ducts, or you're measuring it out through an outlet rather, if you've got gaps to your drywall or to wherever it's kind of coming through into your spaces, these gaps here can incur additional leakage that you may not realize, because when you're trying to get the air into the space, some cases it will go in behind these little openings that are never done. In larger systems, you're likely also going to have access doors and access panels. So making sure that these don't offer any additional leakage that really hurt you along the way. And then just being mindful as well. I always like to kind of throw in some other examples of hidden thermal bridging in the duct insulation or damage insulation for low clearances. Don't really impact your pressure loss or your leaky ductwork, but really kind of impact some other things along the way. And some wonderful more examples here. We had a project that was submitted for certification that was missing entirely insulation on a duct run to the outside. Some hangers that were going through insulation, just really not that great, especially when they result in a reduction in the insulation. Can just really be terrible for the performance of the system. And a little bit on balancing reports. This is often where we struggle with when we get information from our CPHDs. We get balancing reports that are scanned printouts. So somebody prints it, they scan it, and then for some reason they send us the scan, which is a little awful. It's like, how do we get the data from that? Or we'll end up with, almost 200-page documents where we have to kind of extract the data from a PDF somehow and make it work in a way that we can make it legible and to test the values. So it's very important that you specify that, your reports need to be digital, but also provide like the file format. Like Excel is wonderful. If you're into the PHP often, you inherently will develop Excel skills. So it's really kind of fundamental that you get the data that you need in a way that you can review it quickly. It's very important. So I have an example here of a project that we had that had really kind of terrible duct leakage with the initial run. So I've got this table here where we're looking at the first round of commissioning. So we received a really lengthy commissioning report for this particular project. And when you sum up all of the airflow coming out of the outlets and then the airflow coming out of the fan itself at the ERV, there was a huge discrepancy. So you can see in this little red box, this is over 2 ERVs. We had a highest disbalance at 45%. And this was likely due to excessive leakage through the duct network. But we had a hurdle with this project, and it kind of happened right around COVID. So it was kind of hard to get the information in a timely fashion. But the drywall was installed and the finishes were installed. So it was really hard to go back and say, hey, can you try to find the duct leakage that's there, or to remeasure, after you've made adjustments, because people were already living in the suites. So understanding the sequencing that you have to do for your duct leakage testing or even your commissioning is very important, so that you still have that time frame to make sure that you can adjust things and investigate if you need to. So with the second round of adjustments, where for this particular project, we adjusted it at the ERV itself. We were able to adjust the fan reading at the ERV to get within that 10% ratio that we needed for our certification. It just took a lot of back and forth, and I think it took probably a little over a year to get all of this sorted. So there's a huge delays in certification that if you don't understand the sequencing, or if it's submitted to your certifier way late and there's issues, it's like, how do you fix it? So understanding the impact on the certification is really important for this work. And it's what a lot of people don't seem to realize when they get into these larger projects is the timely fashion of submissions. It's really important. This is one of the bigger projects that we had an issue with. 45% is quite staggering when you're looking at a difference between the sum of the outlets and the ERV itself. So a little bit on the readouts at the machines. Here's an example from the Squegon controller where you can actually go in and see what the fan is giving out for an airflow, but you also need to make sure you test this with a traverse measurement in the duct itself. Just because you can inherently, we run into issues where the software on these controllers is out of date. So that creates issues with, is it actually giving us the right information? So testing it with a traverse measurement is very important. And you want to make sure that, you don't have any leaky cabinet doors on your ERVs, because you wouldn't believe how frequently that's actually an issue, where doors have to be replaced or things like that to make it actually work as intended. Now I'm going to pass it over to Michael, and he's going to speak a little bit more of his tales from the trenches.
Yeah, thank you, Kelly. And I must say, when we first started talking about this presentation, it was inspiring to hear that, there's, Peel is working on very similar issues and dealing with very similar, problems in the field on projects in Canada as well. So let me just get my screen up here. Okay, can you see my screen? Great. So, I think this is important to frame a bit of the conversation that I'm, going to present here. The elements of a large-scale multifamily passive house, and talk about a little bit just quickly about the context here, right? Ken had mentioned, we're sort of hyper-focused on the airtightness of these buildings. So, ventilation becomes even more important. We've created this very airtight box, and we really need to make sure that, fresh air and exhaust air are ventilated in correct manners, right? These are the lungs of the building. If this isn't done correctly, you can have all sorts of issues with mold. Wouldn't be using all of the benefits of the passive house certification as a result. So let's talk for a moment, just again framing the conversation with some of the recommendations and requirements for passive house and how they might affect the design. So starting just here from the top, as far as energy efficiency, typically it's recommended that fan motors and ERVs or HRVs are consuming about 0.765 watts per CFM. This is a recommendation, and it's not a stern requirement, but typically we're seeing oversized units using a larger fan spinning a little bit slower to reach this watts per CFM target. Now, verifying the final wattage is not a strict requirement, but is sort of an internal standard that we have set here at Steve Winter Associates in conjunction with our commissioning team. To move on here to balancing, this is a requirement outright. Supply and exhaust flows must be within 10% of each other. That's at the ERV unit. We are targeting a very specific air change per hour rate, and that's all for a reason and built into the standard now. I think it's also important to mention that we should really be targeting those minimum flow rates and meeting those within the apartments themselves, especially on the exhaust side. Again, if we aren't meeting minimum flow rates that are in the design, right, we can of course end up with issues, improper ventilation. Some recommendations on actual balancing within the apartments are shown here. We're always requiring a third-party balancer to do the work of the actual adjusting, the testing, adjusting, and balancing of these systems. And we're always requiring, very strongly recommending a meeting with the tab contractor before work starts on the project. So, why does ventilation system leakage matter? I think I have a few examples here. We'll get into some graphics and details that show the importance here, but let's start with what duct leakage is, right? Here you can see a duct that was pinned up against the wall, and the back seams weren't sealed, right? You can see smoke pouring through them. This is during construction. We often hear, right, our ducts can hold water. it's hand sealed. You can see the sealants on there, but it's not true, right? This is actually very difficult to get low, very low duct leakage values, just using hand applied sealants, which we'll get into here in a moment. What else can we see in duct leakage? This is actually a shot from the inside of a duct using a borescope during the commissioning and balancing process. There was an issue with getting flow rates, exhaust flow rates on a specific branch of the duct. And here we can see, this picture speaks a thousand words, right? Here we're seeing what we assume is the electrician pulled the wire through, was running this wire and had broken off the ductwork behind the wall. Walls got closed up, and of course we weren't getting any flow rates. So there are things that can happen to a fairly well sealed duct system after the fact, right? That can also impact duct leakage. Also, we see a lot of accessories, mixed in. I think Kelly did a great job of highlighting some of these earlier. That gap to sheet, the gap between sheetrock and duct is actually a very important, critical juncture. Right? This gap is essentially under the same pressure as the duct system, and therefore you can lose a large volume of air through egregious gap like this, right? And also, this is where things trade hands. What trade is actually responsible for this? Is this the mechanical contractor, or is this the painter, or someone else who's doing caulking or installing caulking? The solution is fairly simple, but who's actually responsible? We also see equipment leakage through these large rooftop units, Wagon or other brands. Oftentimes the electrician has to run upwards of 10 wires through the unit, and usually they're coring a hole, an inch plus, right? So you can have leakage at the unit if it's not sealed. And here's another example of equipment leakage where we had gotten to the commissioning and balancing phase of the project, and no one could figure out why there was zero exhaust flow going through the building. And it turned out that the shroud, the white shroud that you can see here on the first fan, had blown off, was disconnected from the exhaust side of this airstream, and essentially the fan was totally disconnected from the ductwork. Right, a simple fix, but caused a lot of hardship during that stage of the project. So, duct leakage has an impact on our passive house modeling, particularly if we're accounting for things like fan wattage and higher flow rates based on the balancing. This is an example of a project that had some very high levels of duct leakage in the upwards of 40%. And this was when we had first done first review of balancing and inspections of the ductwork system. And I think it's important to glean, through this graphic that, with high duct leakage and increased fan power, you can actually add a substantial amount of EUI to the total project's energy use. Here was about 2.5%. Now, obviously, they work to remediate this as best possible, but I think I'm showing here another point is that Passive House does a great job at reducing our heating and cooling loads to very low level. The big assumption is then hot water becomes a larger chunk of that energy pie. But I think this graphic also shows that ventilation can start to encroach and grow, take up a larger portion of that energy pie if it's not installed correctly and we do not have the adequate duct sealing. So another graphic here to show a few predicted. This is all in the metric of wattage per CFM of the ERV units in this case, versus the verified fan energy that we were actually finding on site. And I've set a few baselines on the graphic here. You'll remember the 0.76 watts per CFM bar that we talked about earlier as recommendation. And then below that, exhaust only that we've studied on large buildings shakes out to be about 0.36 watts per CFM. So folks that are coming from typically code-built construction go to passive house, right? They are seeing an increase in fan energy. Now, can we spot which projects have high duct leakage? Right, it's projects here A and B. With significantly high duct leakage also comes higher fan wattage. Now, they're relatable, right? The metric is watts per CFM. So if we have higher watts per CFM, it's tagged along to a higher flow rate. It's sort of a double whammy to the energy model. can significantly increase the energy consumption of that system. And here's just a graphic to show you what this might look like when we're verifying flow rates. Some units like the Swagons have a built-in controller with an energy monitoring screen that shows you in real time what the fan, specific fan power is here shown. All right, I am going to get into best practices here quickly, and then I will pass it on to Kelly again. So historically, our firm has addressed duct leakage and duct sealing using this aerosolized approach. AeroSeal is a product that's been on the market for some years now, and it can be a very effective way to seal the ductwork. Now, this is only sealing the ductwork. We mentioned a few of the other areas you can have leakage within the equipment or within the accessories. This only seals ductwork, but it can be very effective. Essentially, that entire duct system is capped off and pressurized. Sealant particles are misted into the duct system, and they build up at all the leakage locations. So you'll see that before and after shot. Typically, this can seal about a half an inch. So it's still important that good hand sealing practices are used, but can be a very effective strategy to getting essentially, we've seen down to 1% or less than 1%. For example, at Cornell Tech, they were less than 1% duct leakage on that project, which is very impressive and just as a testament to this can be done using good practices. Now, I did want to mention specifying AeroSeal. If you're working on passive house projects and you're working on using, having aerosolized sealant application as part of the project scope, I would strongly recommend here specifying it in a particular way. Essentially, there's two ways you can specify using the SMACNA standard here shown on the left. I just wanted to point out that is quite, has an outdated standard, right? It was originally written in about 38 years ago. I think that's updated 39 now. But the standard is old and, is essentially inadequate for high performance buildings to reach the low levels of duct leakage that we'd like to target. I would recommend AeroSeal's 3% fractional leakage spec. I've pulled it out here. This comes directly from the manufacturer. You can find it on Google right now if you'd like, and is a very effective way to get approximately 3% of that total air volume specified in your project, right? And just one more note on specifications, right? Why are these so important? This is what really holds that contractor accountable for reaching, the project goals, right? This is always tested at, leak tested at the operating static pressure of the system. So no to the left and yes to the right. All right, and this chart will demonstrate essentially on real project example the differences that you can come across with using that volumetric or 3% approach versus the SMACNA duct leakage approach. Of course, we're recommending 3%. Why is that? For this particular case, this ERV unit, we have 3% across the board, right? Supply and exhaust air streams are both sealed down to 3% duct leakage. As the project was originally specified by the engineer, it was done under the SMACNA duct leakage standard, and here we can see that we're allowing essentially 32% duct leakage using aerosolized sealant. And I just told you we can get that down below 1% duct leakage, right? So 32% is pretty egregious for a new high performance building, right? We shouldn't be allowing 30% duct leakage in a high performance project, and I think that's just inadequate for all of our efforts in decarbonization and building better, right? What's the other problem here is SMACNA standard is actually based on the actual square footage of the ductwork, the physical area of that ductwork. And in this case, there were different square footages of ductwork, significantly different. So there was more supply ductwork in physical area than exhaust. And what that ends up with is an imbalance right off the bat, right? Here we had 32% leakage on supply, 19% at exhaust. So how is the balancer supposed to come in and meet the passive house requirement, balancing these air streams within 10% with, it's already starting at a disadvantage. One last note, we were involved early on this project, and were able to reduce leakage during construction by about 9% throughout this engagement with our passive house team and our commissioning agent. And one sort of concluding note here on sequencing for AeroSeal on a high-rise building. This is a photo during construction a few months ago of the Sendero Verde Tower in East Harlem, New York. We're working on 35 floors, and the big question came up: how are we going to install AeroSeal at 35 floors? Right, it's sort of beyond the capacity of the sealant application. So here's a few photos. This was actually a day on site that we, myself and Dylan from our office were working on this, and you notice that the sequence, there aren't even windows installed, upwards of floor 19. It's still rough in construction. There's no windows, but the ductwork has started. The ductwork's roughed in up to floor 16, and this is where they were starting the injection points. They were sealing downwards from floor 16 after all of the ductwork, branch work, and accessories were installed on the lower floors. So they were able to cap off those areas, seal 16 downward, and then also they came back essentially and sealed from 16 upward. It's been very effective. We've been reviewing tab reports, buildings getting close to becoming occupied, and it's actually worked very, very well. And just a few conclusions here. As I mentioned, those typical specifications may not be enough for our high performance buildings, right? We should really be specifying 3% duct leakage. We are always communicating these nuances with on-site training, reinforcing these early and often. And I will pass it back to Kelly.
I'm just going to wrap up here with a few more of our kind of solutions that we've approached from certifier side of things, but also a little bit of our commissioning, passive house consulting work as well. So one of the things that Michael alluded to as well was a commissioning agent. This is a very important person on our projects. We like to bring commissioning agent or consultant in early to kind of review the design work, review the calculations, review the sequencing, and then they also are part of some of the site work as well to make sure that everything is going in as planned. And part of that is the commissioning plan and plan of attack for making sure that everything is sealed properly and measured properly and testing and balancing is done correctly. We've had projects where multiple suites were sealed off while they measured one suite, and we didn't know if the system would be able to work when everything was open. So making sure that whoever is doing your testing and balancing really understands the process, that it has to be done as though it's an operation and not just like kind of isolating certain things. Michael alluded a little bit as well to different testing standards that are out there and how to properly, and the importance of specifications as well, and knowing the difference between SMACMA, and which uses the area versus a volumetric metrics to assess your leakage. So we like to refer back to a guidance from the Passive House Institute on this, where it's a recommended 2% leakage as a maximum. And this is all done to the EN standards that they provide as kind of guidance for their assessment, which is EN 16798. You'll also get some typical duct leakage standard testing. I've got some stuff here that comes typically from your mechanical engineer. This is stuff that we've seen over the course of the last few years with respect to standards that are called up. So it's just better understanding when you're working in the design stage with your consultants and your engineers, what testing standards you want, and making sure that whoever's doing it understands that as well. There's a bit of a gap with leakage testing in the field, and it's when you're not using AeroSeal, for example, how do you do your duct leakage testing? And having the proper specification and the team that's going to actually be doing the testing understand the testing criteria and how it all kind of needs to come together is very important. We find that nearly every project we get to, we have to kind of walk everybody through and hold some hands and make sure that we all understand what's happening and what needs to happen. So for duct leakage, it is highly recommended that you do testing. For a lot of our consulting projects, we, at a minimum, request that duct leakage testing is performed. Our preference is to have aeroseal done, but sometimes the budgets don't always accommodate that. So duct leakage testing at a minimum to better understand if there is leakage, the conventional means of sealing the ducts, because as Michael said, the contractors are always going to say that they've done it properly and perfectly, but that's usually not the case. So there's always leakage that comes through, and that can really hurt us when we're looking to get everything appropriately balanced. And we should also have your leakage testing done before the interior finishes are up. It is incredibly difficult to convince clients and building owners that to do investigative work after the finishes are done. So we need to make sure that that's all done ahead of drywall going up and the shafts are sealed up so that you can fix anything that you need to fix without having to incur additional costs for a full aero sealing system. So a little bit on kind of what we're looking at when we're talking about duct leakage and the kind of transference over to pressure loss calculations. So the certificates that we get from the Passive House Institute for our ERVs, for example, will have a listing for what the maximum static pressure is. And then as part of the design, you're supposed to be getting also calculations from your mechanical engineers that tell you, okay, my longest duct run doesn't exceed this rate or this amount of pressure. So we often find that when you have leakier ducts, you're exceeding this metric and it does incur additional energy consumption. So you have to ramp up the fans to make sure that everything is getting enough airflow. So it's very important that in larger buildings, that in design, this is done and then also kind of followed through with construction as well. All of the information is available in design if you've got your units selected. So there's really no reason to not kind of get your head into these calculations and better understand what it is you're trying to achieve. This is just a commissioning checklist that we typically use when we receive commissioning reports as certifiers, kind of things that we go through to make sure that everything is done properly and in line with what we have to submit to the Passive House Institute for certification. There's a lot of little nuances that are kind of required with respect to balancing and the commissioning reports. And I just included this as a good reference because there might be people out there who would want to have just a kind of a preliminary checklist to go through as you're kind of getting into your larger projects or your multifamily. So some key lessons from North America. We want to, oh, here we go, went too far. We want to clarify the requirements with your certifier early on. You need to, obviously, as we keep saying, I repeated it a few times, Michael did as well, integrate ventilation into your early design, making sure you're doing the calculations that you need for your pressure loss. You've got your commissioning agent on board as early as you can. And if you're able to, and the budget permits, specifying aeroseal. It's very important that these ducts get sealed up. It really kind of helps speed up the certification process and ensures that we don't have that huge performance gap when we're looking at what our PHP says and then what we actually get at the end of the day. And yeah, complete your duct leakage testing before as a pre-commissioning. So before you cover everything up, making sure that you're doing your leakage testing or your sealing at that point. I like some of Michael's examples that he had where construction was still very much underway, and they're sealing the ductwork, which is exactly what we want to see. You don't want to wait until you've got drywall in and everything kind of covered up so that you can't access it. So that's it for me. So back to Ken. I think we've got a bit of a Q&A.
Great. Thank you, Kelly and Michael. That was terrific. A lot to take in. You get a sense of how important it really is. I mean, it's shocking to see the effect, not just, well, first on the energy use of leaky ducts, but also on the overall performance in so many different ways. I want to just reiterate and put questions into the chat. We've got a lot of questions. We'll try to get to them as we go through this, but I do want to punch up a couple of things. One, just again to reiterate and reinforce the idea of ventilation early design. I think it's one of the interesting things that's come up, especially looking at multifamily buildings. You know, we think of form factor, we think of the enclosure and the insulation levels, the window quality and whatnot pretty early on in terms of the modeling and the planning of the project. But I've heard again and again from experienced people who are doing a lot of these projects that the successful ones really have ventilation for a whole bunch of reasons in the very beginning of the planning, and realize just how critical it is to achieving passive house performance and certification. So I don't think we can emphasize that enough. Where do we want to start here? One thing I want to touch base, not directly into the questions yet, but the issue of training and the issue of traditional approach and working with the trades, having the commissioning agent there, and how do you kind of successfully, and these are big projects, you know, and you're dealing with union labor or non-union labor. Some have quite a bit of training, probably others not as much. Do you see any patterns in terms of success for training in the execution of the installation? Or is it really just a matter of being on top of it the whole way? Michael, do you wanna?
Yeah, I can take that one, Ken. Thanks. Great question. Yeah, I think, generally it can scale with the size of the project. Honestly, the smaller projects tend to have more issues with perhaps less training and a less sophisticated outfit that's actually doing the work. I think, reinforcing this through a contractor training that's held before any of this ductwork is installed, right? And, explaining essentially that really the installer is the first line of defense, the general contractor is the second line of defense, and then we as the inspector and verifier are the third line, right? So really there should be many eyes on these topics, and I think we're also very upfront that many of the projects that we're seeing are passing our blower door test, right? This is really the sticking point is on ventilation. Getting the ventilation installed correctly is a huge factor. So I think that's how our approach has been to sort of reinforce this throughout construction. But yeah, excellent question. Not sure if Kelly has anything else to add to that.
I just wanted to kind of further cement the idea of training for these teams. We find for the projects that we're consulting on, we kind of work in training requirements for all the trades. It has to be done. You have to kind of validate either your previous project experience or a CITIC course. And we find it really helps them kind of understand what we're trying to achieve, because a lot of people don't understand that some of these systems are going to be tested a lot more than the conventional way that they've been building things in the past. So I'm kind of instilling that apprehension when it comes to what it is we actually need, and understanding the bigger goal is really important. And I think that it's very kind of integral to the process to have training as part of the process, especially for these larger projects.
Yeah.
Just to make sure, yeah.
So there's a lot of mention of AeroSeal and how it fits or doesn't fit, works, could it cause problems? And so just to dive into a little bit, what it maybe encompass a few of the issues. I think you spoke, Kelly, of the idea of AeroSeal is one approach, but also the idea, and I think there were some comments about like also setting yourself up for success without AeroSeal, right? And what is the more traditional, if I could call it that, traditional way of air sealing pre-AeroSeal? And the second part of that would be then there were questions about do we see AeroSeal like not being effective necessarily in some conditions where if the ducts aren't pressurized, or can they mess with some of the controls or accessories that you have? What precautions do you need to take there? So two sides of that.
Yes, that's a big one, Ken. So what for the AeroSeal itself, like we work with a lot of, like we consult on a lot of social housing projects. projects that have low budgets, low capital budgets, and it's hard to get additional money. So sometimes we find that specifying aeroseal is kind of outside the realm of what building owners can kind of allow for at this stage in construction. So we try to make sure that we are inclusive as best we can to ensure that we still get decent design and decent work out of the contractors. Part of that is just kind of saying if you're going to do traditional duct sealing, which is, I think Michael had some examples there, they just kind of apply a coating as they put the ducts together and then seal up the outside with a bit of a mastic coating. And, that's supposed to get us what we need. A lot of times it doesn't. So if we have mechanical contractors who come back to us and say, oh, we're going to, our sealing is really good, we're going to go over everything 2 or 3 times. Well, okay, well, now we say, well, prove it to us. Do a leakage test. Tell us that you've done it properly. And if you haven't, then your fail-safe is the aeroseal. And that's kind of how we work it in to say, here's a more cost-effective means of getting our kind of airtight or sealed up duct network without actually having to come back and say, yes, please pay for aeroseal. So it kind of makes sure that they have that due diligence when they're on site. And if they know it's going to be tested, they're going to likely do a better job.
You take that aeroseal backstop out of their profit at the end of the day.
Yeah, pretty much. It's kind of like prove it to us, and if it doesn't work, then this is what you have to do.
Yeah.
So I'll leave the second half of the question to Michael if you wanted to jump in on the accessories that go in.
Yeah, Ken, maybe you could repeat that second half of the question. I was still thinking about aeroseal and its application versus traditional seal. But...
Yeah, no, well, feel free to continue on that as well.
Sure.
But also the accessories was just, is there any concern about when you're blowing the aeroseal gumming up or adversely affecting any of the other accessories or aspects they need to protect against?
Yes, you absolutely need to protect. Things like VAV boxes cannot be installed at the time of aeroseal. Fire smoke dampers need to be put in their fully open position. There are very specific details around that are laid out by aeroseal's installation manual. The benefit, though, is they can be, installed in this retrofit sort of application. And I think I did see another point in the chat of, is there concern for occupants when you're doing this in a retrofit application if tenants are still in place? And there's certain precautions. Again, it's all in aeroseal's literature on how to protect an occupied building. You're capping off, the ducts within the apartment, and then typically they're using scrubbers with very good HEPA filters to remove those aerosolized particles afterwards. So, but yes, you absolutely need protection.
If I could just reframe the first part to you, Michael, is since you are pretty much mandating aeroseal in your projects at scale, right? If
Yeah.
I think I've got that right. What are you specifying, pre-aeroseal? Like, you're not solely relying on that, or are you?
That's a great question. We are also, in conjunction with that, requiring through the specification that good hand sealing practice is used, and that's typically reverted back to the SMACNA standard. And there's a Class A installation, which means that all seams of the ductwork must be physically hand sealed, hand applied sealant. So that is how we're typically use our backstop. We've had some projects that have said my ducts can hold water. I've been through this 3 times, and we have a similar approach to Kelly, where we say, okay, prove it. They do a duct leakage test, and it's 30% duct leakage, and soon enough they'll have out the aeroseal rig, and they'll be installing the sealant. So we definitely provide some flexibility, but oftentimes they aren't able to hit this level of leakage with just traditional practice.
There was a question on at the dampers, the flow rates that we're getting and dealing with this. Are you typically using in these large buildings the constant air regulator dampers, or how are you able to achieve the flow rates and hold them? And on the measurement side, the question of traditional flow rate measurements and the accuracy, and what kind of tools are being used to make sure that we're getting accurate measurements, verification.
Yes, I could take the first stab and pass it to Kelly. Yes, we are almost always seeing car dampers installed. There are some new products to the market, but they tend to be more costly, especially if you have thousands of these, right, in an apartment building. So car dampers are a traditional approach. And then to your second point, we are relying on a very accurate flow measurement device used during the balancing phase. And this is, again, something that we are baking into our project manual and specifications. But a low flow powered flow hood, there's only really like 2 manufacturers on the market. Retrotech makes one of them. They tend to give you the accuracy at a very low flow rate that's needed for this. But also you need to understand that there's always a plus or minus. There's a plus or minus of 3% on the flow hood. There's a plus or minus of 5% on car damper, right? There's always a little bit of this. So accuracy is taken with a grain of salt.
Follow up and say, yeah, we also have a lot of car dampers on our projects. We also use the Suite on React damper as well when we're looking at kind of modulating for different suites to give everybody that kind of independent or individual kind of boost setting. And then just a second, I really caught up on the Suite on dampers there. But yeah, no, it's the flow hoods. Yes, no, exactly. There are only 2 kinds. That because we always have these low flow rates for passive house, and the conventional means of measurements don't go that low. And so we kind of make sure that whoever has been contracted or selected through the procurement process understands that, so that they do have the proper equipment to measure what we need to measure, so they don't get decided and say, oh, it's more money now because we don't have the right equipment. It's very important.
Right. Good. I think there's some questions about, talking about decentralized versus centralized. And I think ventilation systems and, one of I'll just kind of jump in to address it if you want to add anything. I mean, if you're going to decentralize, you're avoiding all of these issues we're talking about today, right? These are what we're looking at is big building systems. Do you see with owners or repeats or project teams taking this into account when they're looking at decentralized versus centralized systems, or is it just pretty much moving to centralized at this point for big buildings? Like what are the factors there? Slightly off topic, but Kelly, do you want to start?
At the same time? Yeah, I'll go first. We often work with centralized systems just because it does incur a lot less like maintenance costs over time. If you've got 100 unit building, you don't necessarily always want 100 different ERVs. So a lot of the bigger buildings that we contend with, both for consulting and certification, are going to be centralized systems. So this is just a common thing that we have to kind of contend with. I think, Michael, you might have a bit more practice there with some of the decentralized applications.
Yeah, for multifamily buildings, 3 floors or unders, we have seen some decentralized units. Now, when we get to high rises, we have been pushing away from them and moving towards centralized, ventilation units because of numerous factors. But some of the biggest ones that I see, Kelly mentioned maintenance, which is very true. Also, the actual grill on the exterior of the wall, it builds up dust and it gets essentially coated, fully sealed in dust. We've seen this on a project that's been operating for 4 years, and that no one gets ventilation air in that case. And the only way to physically access it is by essentially dropping like scaffolding rig to come by and clean those, and that can incur a significant amount of cost. So centralization has a lot of benefits in these large scale, high-rise projects.
Terrific. Well, so there's an argument for this and for solving this problem and making sure that the teams are able to execute and it's getting commissioned. I think we're right at time. I'll resist the temptation to keep asking questions because we could go for a lot longer. And we could follow up if we do have the questions in the chat, and if I see something particularly interesting, we can pass it along and distribute it out. I think we can make the presentations available. And the video will be available in the next week going forward. And I hope that we can, through the Certifier Circle, convert a bunch of this information, and we'll edit it through and create a little resource for folks going forward. So everybody's learning and benefiting from your experience. So thank you both very much. Super informative, and looking forward to more talks like these. Thank you everyone for coming. Again, happy Valentine's Day. We'll announce the winner in the next day who will get this award book. It is available for free download, a PDF on our website. We have a few of these. I think we're going to be giving them out as gifts in various ways going forward. So thank you, everybody.
Thanks, Ken. Thanks, everybody, for joining. It's been great.
This was
Thank you,
terrific.
Ken.
Have a great day.